Okay, this is Nick again, and I will be continuing on this series of videos about developing graphs. We are still on the distance time graphs in physical science. Alright, still on part 1, section A, distance versus time graphs. There is a difference in this video, and the difference is really in the fact that we're now beginning to introduce negative. In the previous videos we didn't have anything that was negative. In this video we're going to have at least one example of the velocity being different, meaning that the velocity is going to be negative instead of positive. So we'll see that when that happens. Okay, we are still the type of graph, and we're still using straight lines. We're still not introducing curves yet. Alright, this is our first one. Quite a little unusual. The object begins at some point, continues to move without the passage of time. Sort of wonder, can something move and time doesn't pass? Okay, this is not possible. Time cannot remain at the same number. In this case, time is not really 0, but at some point it starts to move and then there's no time. The object's velocity is 0 because the time is 0. The object's acceleration is 0 because the velocity is 0. Alright. For the slope is obviously the velocity, which is 0 because the change in x is going to be 0, even though the change in y, or the change in time, has a value. The change in time has a value, but the change in x is 0. There's no relationship between, no direct relationship between distance and time because it doesn't qualify. It is a straight line, but it didn't start from the center of origin. And of course, in the equation, equation means nothing really because x is 0. Okay. Okay, in this one, well, I was able to put some numbers on the graphs. The numbers are not exactly equidistant, but I guess in the next video I will make them a little better. But in this case, the object starts from the origin, and there is constant velocity. It's changing the distance with respect to time, and then the object stops moving. So the object stops moving as indicated by this straight line. See, the distance is no longer, goes up to 2, which is here, and it stops. Okay. But in this case, that is very possible because the time still continues, which is what happens. If something stops, time doesn't stop. Object is moving away from the origin, or away from the point of origin. The object's velocity is constant for a part, and then it stops. Acceleration is 0 because the velocity is constant, and then the acceleration is 0 because the velocity is 0. The object has stopped. Alright, remember that distance, positive, although we don't usually consider distance as being positive or negative. We consider displacement as being positive or negative because it's a vector. So velocity is 0, acceleration is 0. The acceleration is 0 throughout the entire distance. The slope is the velocity at the beginning. It it is positive. There's a positive slope at the beginning. See, this is a positive slope, and then the slope becomes 0. All right. There is a direct relationship between distance and time from here to here. Okay. And then there's no relationship. Okay. All right. For this one, the object starts with constant change with respect to the time, constant change in distance with respect to the time, which creates constant velocity, uh, and then it turns around. Here's where we're beginning to introduce the negative. Right? Remember, this is the distance. It goes up to 2, comes back down to 1. Well, comes back down to 0. Um, and here is where we have displacement. This is a very good example of displacement, in that the object begins to go in one direction to the right, stops, and then the object begins to come back in the opposite direction. Right? Opposite direction. Okay, the velocity the velocity is positive in this direction, and then you still have the constant velocity in the opposite direction. And of course, that constant velocity in the opposite direction makes it negative, so the velocity is negative. But because the velocity was constant here and constant here, then the acceleration becomes 0 in both cases. Slope is positive, slope is negative. All right. There's a direct relationship in the first part only, but not in the second part, because in the second part you didn't start from the origin, and for there to be a direct relationship, you know, the process must begin from the point of origin. All right, object starts from 0 distance, and there's constant change with respect to time. This continues rapidly, and then it continues to increase the distance rapidly here, bam, but there's no change in time. All right, which is what was discussed earlier. It's not possible for something to be at rest. Sorry, not at rest. Sorry, that's not. But it's not possible for something to be moving like this. Remember, this is moving, but the time remains the same. The time doesn't move. And that is also not possible. Okay, so the object's velocity is constant, meaning the acceleration is going to be 0. Because the object cannot increase the distance, and there is no time. Distance will be positive. Displacement has increased. Alright, velocity is positive, and then it becomes nothing. Acceleration is 0 throughout the entire period. The first section, because the velocity is constant. In the second section, because the velocity is nothing. So if it is the velocity positive, and then becomes 0 or nothing. There is a direct relationship at first, and then no relationship. In the first section, you do have an equation of the line. In the second section, y is equal to 0 times x. 0 times x. Alright? Okay. This is the end of this part of the series. This is Nick, and I will talk to you again in the next video. Thank you.